My name is Alex Galt. I'm a math teacher at Edina High School, and this lesson is about polynomials in the factored form. So when you see a polynomial in a factored form, an easy feature to find is an x-intercept or a root or a zero, and so that will be your goal today. Looking at the factored form of a polynomial and finding the zeros or roots or x-intercepts of that polynomial. A huge idea that helps us find the zeros of a polynomial in factored form is the zero product property. What the zero product property says is if there are two things that multiply to equal zero, then you know that at least one of those things has to be zero. So if I say, oh, hey, 7 times x equals 0, the only way for 7 to multiply by anything to make 0, then x would have to be 0. If I know that x times y equals 0, then I don't know which one is 0, but I know that one of them has to be 0. So that's the zero product property. If a times b equals 0, then either a equals 0 or b equals 0 or both. And without that property, this factored form of a polynomial would not be so easy. But with that property, we think about here's a factored form of a polynomial. What factored means is that it's written as a product, so it's x minus 4 times x plus 2. And if we think about this factored form of a polynomial, we want to know for what x does f of x equal 0? And so we say, well, 0 equals x minus 4 times x plus 2. And so we know either that x minus 4 equals 0, or x plus 2 equals 0, or possibly both. And then we solve these equations. We figure out what x would have to be in order to make that true. So we'd add 4 to both sides of this equation. And so we have x is equal to 4. We can subtract 2 from both sides of this equation. So we have x is equal to negative 2. So I have x minus 4 times x plus 2. I make a graph, and then just a reminder about how we find the zeros. We go menu, analyze graph, 0, and then it says lower bound. We want to click to the left of the 0, and then it says upper bound. We want to click to the right of the 0. So there's one of the x-intercepts, and then if we do the same thing, menu, analyze graph, 0, left of the 0, right of the 0, and so those are the x-intercepts, negative 2 comma 0 and 4 comma 0. Those are also the roots of the polynomial, negative 2 and 4, and it's the solution if the polynomial is equal to 0. It's also called the zeros of the polynomial. Okay, here's a factored polynomial, and it says find the roots of the factored polynomial. And so you can see that it's factored because it's x times 4x minus 3 times x plus 1. It's a product of things. And so we want to find the roots. Well, if the product is equal to 0, so finding the roots means finding where it's equal to 0. If the product is equal to 0, then we know that one of the things multiplied together has to be equal to 0. So we're going to say, take this first thing, x equals 0. So that's one of the roots. There's not really any solving we can do there because x is already equal to 0. 4x minus 3 is equal to 0. That's going to be a two-step equation. We're going to add 3, so 4x is equal to 3, and then divide by 4, x is equal to 3/4. And then x plus 1 equals 0. So x is equal to negative 1. Those are the three roots of the factored polynomial. If I look at a graph of this polynomial, and I'm not going to use my calculator, I'm just going to show you a graph of this polynomial. Here's one of the roots. It happens at x equals negative 1. Here's another one. It happens at x equals 0. And here's that last one that happens at x equals 3/4. So if you have a factored polynomial, it's easy to find the roots of the polynomial. Okay, find the zeros of this factored polynomial. Zeros is just another name for the roots. It means set it equal to 0. So if this is a product of things that's equal to 0, then one of the items must be equal to 0. 3 is equal to 0 does not make sense, so that's not going to be true. 2x minus 3 equals 0. So add 3 and divide by 2. X is equal to 3 halves or 1.5, but whatever. Either answer is fine. 4x plus 1, so 4x plus 1 equals 0. So 4x is equal to negative 1. And so x is equal to, divide by 4, negative 1/4. And then x minus 2 equals 0. Add 2, so x is equal to 2. Just set each of your factors equal to 0 to find the zeros. And here's a graph just to confirm. Here's x equals negative 1/4. You can see that it's about 1/4 of the way to negative 1. X is equal to 1.5. And x is equal to 2. And those are going to be the zeros, or the roots, or the x-intercepts of that polynomial. Okay, this question asks, if you graph this factored polynomial, where would the x-intercepts on the graph be? The x-intercepts are when the polynomial is equal to 0, so it's going to be the same process. The x-intercepts are going to be if any one of these factors is equal to 0. So negative x equals 0, divide by negative 1, and you get x equals 0. So that's going to be one of the zeros, or one of the x-intercepts. As an ordered pair, which is how we generally like to write x-intercepts, we could write 0, 0. 2x plus 5 equals 0. So subtract 5. 2x equals negative 5. And divide by 2. X is equal to negative 5 halves, or negative 2.5. So as an ordered pair, you might write that as negative 2.5 comma 0. Or x minus 2 is equal to 0. So x is equal to 2 if you add 2 to both sides of that equation. So the ordered pair would be 2 comma 0. Here's a graph of that polynomial. Here's the ordered pair negative 2.5 comma 0. Here's the ordered pair 0, 0. And here's the ordered pair 2, 0. Those are the zeros of that polynomial. All right, so write a factored polynomial with zeros at x equals 1, x equals 3, and x equals negative 4. There are lots and lots of different answers to this question, but probably the simplest one is saying, well, I'm going to have 3 factors. The first one is going to have an equation whose solution is positive 1, so how about x minus 1? The second factor will have a solution, if I set it equal to 0, of x equals 3, so how about x minus 3? And the last one will have a solution of x equals negative 4 if I set it equal to 0, so how about x plus 4? Each of these factors, if you set them equal to 0, give you zeros at these points. Okay. So to summarize, the easy graphical feature to find if you have the factored form of a polynomial are the x-intercepts, which are sometimes also called roots or zeros of the polynomial. How do you do it? You set each factor equal to 0 and solve for x. All right, so at this point, you should be able to find x-intercepts for a factored polynomial.